Hello everyone. In the previous chapters, we have jointly studied the relevant knowledge of engineering geology. So how can we obtain such engineering geological information? And how can engineering geological knowledge be applied to serve engineering construction? Engineering geological survey work is needed here. From the beginning of this chapter, we will introduce relevant knowledge of engineering geological survey. The current engineering construction in China includes three main procedures, namely survey, design, construction, and monitoring. That is, conduct surveys first, then design, and finally, the construction. In other words, engineering construction survey goes first. What is the goal of geotechnical engineering survey? The main purpose of geotechnical engineering survey is to find out the engineering geological conditions, analyze the existing geological problems, and make engineering geological evaluation of construction site and the foundation to provide a reliable geological basis for the whole process of planning, design, and construction of engineering construction, so as to take a full advantage of the advantageous natural and geological conditions, avoid or transform unfavorable geological factors, ensuring the safety and normal use of buildings. Geotechnical engineering survey methods can be divided into surveying, exploration, experimentation, and monitoring. Exploration includes geophysical survey, test pitting, and drilling. The experimentation also includes indoor and outdoor experimentations. Before carrying out geotechnical surveys, first, it is necessary to classify the geotechnical investigation grade. The essence of the survey level is that simple problems are treated simply, complex problems are treated complex problems, so that survey work is more targeted according to the provisions of the code for geotechnical engineering investigation. The geotechnical survey grade should be based on the importance of the project complexity level of the site and comprehensive analysis and the determination of the complexity level of the foundation, as well as the importance level of project. Engineering projects based on the severity of potential damage consequences shall be classified into three grades: grade I, grade 2, and grade 3. The site complexity level is, according to site conditions, classified into Class I site, complex site, Class 2 site, moderately complex site, and Class 3 site, simple site. The three levels, when specifically divided, you can refer to the form given in this table to make a detailed division. The conditions of these venues include whether it is beneficial to earthquake resistance, degree of development of adverse geological processes, conditions of geological environment, complexity of topography, the degree of groundwater impact on the project, and other factors. The foundation complexity level, according to regional conditions, can be divided into grade I foundation, complex foundation, grade 2 foundation, medium complex foundation, grade 3 foundation, simple foundation. The three levels. The foundation conditions are classified based on the variety of soil and rock types, uniformity, variations in properties, and the presence of any special soils and rocks, etc. According to the importance level of the project, the complexity level of the site, and the complexity levels of the foundation. And according to this form, we can comprehensively determine geotechnical engineering survey grade, such as project importance rating, site grade, and the foundation grades, as long as one of them is level I. Then the grade of survey is grade A. When all three ranks are level 3, the grade of survey is Class C. The rest of the situation is classified as Class B. It should be noted that the geotechnical engineering survey grade is divided into levels A, B, and C, instead of levels 1, 2, and 3, after understanding the classification of geotechnical survey grades. Next, the division of geotechnical engineering survey stages is introduced. In practical project, planning and the design process of any project must follow the principle of gradual progress. According to the division of science into several stages, select the site first, then carry out the preliminary design, and finally design the construction drawing. Corresponding to the construction phase of the project, engineering geological surveys are also carried out in phases, divided into feasibility study survey, preliminary survey, and the detailed survey. In addition to the 3 stages, when necessary, construction surveys are also required. The feasibility study survey shall comply with the requirements for selecting a site scheme. The preliminary survey shall comply with the requirements of the preliminary design. Detailed survey shall comply with the requirements of construction drawing design. When site conditions are complex or the project has special requirements, supplementary site investigation during construction is still required. The following is a detailed introduction to geotechnical engineering survey. Each stage. The first is the feasibility study survey, with the main task to select the site or route scheme of buildings by surveying, evaluate its stability and suitability. After technical and economic demonstration, choose the best solution. The methods of survey include collecting data, survey, and the geophysical prospecting methods. The main task of preliminary survey is to determine the specific location of the building and select the foundation scheme of building foundation and demonstrate the prevention and control measures of unfavorable geological phenomena. It is also necessary to identify the engineering geological conditions of the construction site in detail site. Survey methods employed include drilling, test, supplementary mapping, and geophysical prospecting, as well as supporting some long-term observation and other means. The main task of detailed survey is to cooperate with technical design or construction drawing design to provide detailed engineering geological data for different buildings and geotechnical engineering technical parameters required for design. The survey methods are mainly test and supplementary investigation for complicated engineering geological conditions, or the project has special requirements. Construction surveys are also required. It includes construction, geological catalogs, trench inspection and monitoring of foundation, and the construction advance forecast, so as to check the existing survey results. This concludes the introduction to the fundamental knowledge of geotechnical survey. Please complete the after-class exercises for this lesson. Thanks.